This conference will now be recorded.
Yeah, so after having all this thing in place, what you want to know? So this is the most important topic. The cluster setup is done, but after that, what you want? So there's so many resources which we have, which you must get comfortable with it. So some of the resources which you want to see, kubectl. These are the commands which you need to learn actually one by one. Okay, one by one, most of the commands you have to learn. This is your basically work. Now, which are the resources you want to create? Remember that API server is nothing but a place where you have all the features. So these are the resources which you have to create. These are the resources. Let me count today how much. 57 it was last time. So grep 72. So now we have a new version of this one, have 72 resources. And these are the things you have to learn, these 72 resources. So how do we get started? So I'll teach you some of the resources. These are the resources here. So left side you see here, these are the resources. This is, you have a short name, API version, the release of it, namespace true and false, which I'll talk about it, and kind. So this is something which we have to understand. So what are the resources I'm going to teach you? The first one is you should understand namespace. Then second, I'm going to teach you pod. Then third, I'm going to teach you replication controller. Okay. Fourth, I'm going to teach you deployment. And last one, which I'm going to teach you, services. Okay. So only these are the resources I'm teaching you, but most important one. So guys, all of you know AWS, right? Correct?
Yes.
So can we correlate the services? So this is namespace. You can think of in AWS as like an account, your account. Just visualize that, not correlate. I'm just trying to help you to correlate in your mind. Pod in AWS means VMs, EC2 instance. Replication controller is nothing but an auto scaling group. Deployment is also auto scaling group, but plus million features. And services is, this is the load balancer. Okay, so something like that you can correlate in your mind. That means AWS, whatever you have, something similar you can get it in a Kubernetes cluster also. So AWS is also platform and Kubernetes is also platform. Are you understanding?
Yes. Yeah, right.
Okay, so now the first question is, what is a namespace? So guys, understand this. This is the cluster. This is the cluster, and powered by how many worker? So this is one worker, 2 worker, and 3 worker. This is the 3 worker. So now if you have a 4 GB RAM here, 4 GB RAM here, 4 GB RAM here, so what is your total cluster size? 12 GB, correct now? Correct?
Yes.
So this cluster is of entire organization. So how many teams you have in your project? Let's say this is a one team and there's another team. Now you know what? These two teams will keep fighting. For what reason? So let's say this team, this is the red team, have deployed the pod. So one pod got created here. Remember, pod has a container, so which has an application. one pod here, one pod here. Now green team also deploy their own pod. Now what has happened? This red team is using more resources. See, totally you have 12 GB resources, but red team is using more resources. So now green team is fighting. You should not use so much of resources. Started blame game, this, that, and all stuff like that. Sometime what happens, because all teams are working in the same cluster, so sometime by mistake they will destroy someone else configurations. So how do we deal with it? Like, how do we deal with it? Like, you have only one clusters for the organization. How do we share that cluster to the multiple project, multiple department, multiple team, multiple client, and restrict their access and resource allocations? Are you understanding?
Yeah.
So that is where that Kubernetes has introduced one concept called namespace. See, namespace is not a physical distribution. Mind it, many people think physical. Namespace is not a physical thing. It's not like, hey, you take one server, I'll take one server. No, it's not like that. It's a logical, again, see this vertical, logical. That means this guy also, this project also run the pod in the same server, but this guy also run in the same server. But if you set, let's say, this project cannot use more than 4 GB, so this pod, this pod, this pod combined cannot go beyond 4 GB. Same goes with this also. And now after that, let's say if you set the access for this guy, only this, so he will not be able to do anything here. Are you understanding?
Yes.
So this is called namespace. So few namespace already there actually. Let me show you here. So here kubectl get namespace. See, these are the few namespace. So one is a default for everyone, and this namespace they are running the pods, which is important for the clusters. Did we talk about this pod? All of you, tell me. Recollect and tell me, did I talked about it?
Yeah. So proxy API server. Yes, we did.
Yeah. Right. So here you see these services I talked about, you know. So see here API server, controller manager, etcd where exactly? Here it is. Scheduler where exactly? Kube controller here. Oh no, this is not a controller manager. This is a controller manager. Scheduler is here. Now why we have a two proxy? Any idea?
Because we have two nodes.
Yeah. So I told you, no, one proxy master, one proxy worker. So this is the two proxy. Now here I said code DNS. No, these are the pod for the, this is a pod for code DNS, and these are the networking services Calico and all got installed. Okay. So yeah. So there's the namespace. This is for administration purpose. This is for anyone who wants to create in the default. Admin team can use this for the node troubleshooting and all, maintenance and all. Public means common one for the all the projects and all. So what to do? So guys, here I have a multiple services, API resources, multiple resources. So how do I work with it? So I'll teach you one simple pattern which will be helpful for you. Do you know CRUD, right? All of you?
Yes.
All of. So what is the meaning of CRUD?
Create, read, update, delete.
Yeah, so create, read, update, delete. Just remember this pattern. So whatever the resources you see here, you need to do just CRUD. you should know what exactly those resources are, and you need to do the CRUD. So you need to create, read, update, and delete. So there's a two way you can create. One is like a command line and one using YAML file. I'll teach you both the way. I'll show you the demo. Okay. So command line means what? So let's find out, because I don't know. So I will ask kubectl, hey kubectl, give me. So here I'll go through this and see there is a command for creating any resources. So how do you do the YAML? Create -f. Now, which command should be used for read? So there is a command for it, which is here, get. You see here. And how do we do that? Through YAML. Here, .f and YAML file. Okay. So this is the stuff. How do you do the update? So read, update two things using command line, YAML file. So command line, how do you do that? Edit. YAML file, how do you do that? Apply. How do you do the delete? I think delete. So this pattern, if you remember, you can apply for all this. All these resources. Are you able to understand this pattern?
Yep.
So any resources you have, sorry, any resources you have a create, get, edit, delete command line. If you are doing through the file, YAML file, create -f, get -f, apply -f, and delete. So can we do with the namespaces, which is here? Can we do with it? So let me do with it. So kubectl get ns. I'm just reading it. Create ns, dev ns, qa ns, 2 ns. I'm creating namespace. This I'm using shortcut. Okay. See, you got created the namespace, right? So you want to edit the namespace, edit ns, which one? Dev. You want to add some labels into that. So here, service web, save it, get ns. How do I see the describe? ns dev. See that label? Understood, all of you?
Yep.
And how do I delete it? Get ns and delete. So kubectl delete ns, give it done. Sorry. See, gone. So this is how sorry. So this is how you can do with all the resources. CRUD rule. Now can I do with the pod? So pod, I'll show you through YAML. So where do we get a pod? Let me go to this blog and pod example. I'll just search for it. And here you have it, multiple examples. In this file you have this one example, two example. You can go for this. So see here, this is the YAML file for creating a pod. Let's understand this. So what you want? Pod. Which is the API version? V1. What is the name of the pod? Pod contains container. What is the pod specification? Containers. Which container? Image from this. This is the image which is customized image actually. I pushed it into the hub.docker.com. Are you understanding, all of you? Yeah. So these are the minimum fields which you have of the pod. So copy this pod, go to here, and vi pod.yaml, paste it. Done. Can we save it? Now I'll follow the same command which I taught you. Okay. And we'll do the CRUD. So what to do? kubectl apply -f pod.yaml, or create -f first. Create. Let me create -f pod.yaml. Where it got created? So it got created in default. Get pods. You see here. It's creating. Can I create one more pod in the same? See, same name you cannot create in the same namespace. Can we create in the dev namespace? -dev created. So here you got it, one pod. This is the default. This is in the namespace, which is a. Understood, guys, all of you?
Yes.
So I created a pod. I read the pod. I can describe the pod also. So kubectl describe pod. Which pod? This is from the default. This is the complete details of the pod. This is the IP address of the pod. So here you see that -o wide, you get this pod is running state. There's only one container inside it. Age IP address of the pod is running in this worker. I have only one worker, so like that. Can I access this pod? 80 port, it's I know that, so curl http, here it is. So welcome to DevOps School version 1. It's running right now. So I did get. Can I edit the pod? Yeah. So kubectl edit pod. Which pod? This pod. And this is the edit mode. What you want to modify, just add one more labels. Service service Raju, team name dev team. I added, and describe this. Go up, see it here. So you can edit the pod also, same command. And then finally delete the pod. So can I delete the pod? kubectl get pods, kubectl delete pod, name of the pod. I deleted in the default namespace. Now kubectl delete -f pod.yaml -n dev. To the YAML file I deleted in the dev also. So this is the way I did work with pod, following the CRUD operations, and showed you. Am I making sense now, all of you?
Yes.
Now the question is, okay, the pod you created, but how do I work with it? So there are many commands which we have actually. I don't know, but you have to know actually. These are the, see here. These are commands. These commands has been given to work with the pod and container. Describe, logs, attach, exec, put forward, proxy. I'll just remove it, not required right now. And debug, I'll just. So these commands you can work with the pod actually. So describe command I was using a lot. You might have seen this. So here kubectl get pods. There's no pods. So can I create one more time? So kubectl apply -f. You can, instead of create, you can directly apply also do that, because apply has a create feature also embedded. And you see that it got created. One pod got created. What is the IP address for this? White. And here this is the IP address. So can I see the logs of the container, not a pod? See here. Again, mind your keyword in Kubernetes. Pods cannot have a log because not a physical entity, it's a logical entity. So logs will be generated by container, correct now?
Yes.
So mind it. So here can I, so if you have one container in the pod, you can use the container pod name. But if you have multiple, then pod name plus container name also you have to use it. So kubectl logs of this container. See, there's no logs. I have to hit this. Let me hit from the other boxes and curl http. So this pod will be accessible inside a cluster anywhere. See here. Welcome to DevOps School version 1. But now you see that one logs will be created here. And -watch. No, there's a one combination, watch combination. So just a second, let me get it. -h you can use for the seeing the all other options available. So do you see watch? Tail, I think. Tail, I need to understand. Okay, so this is something like this. Okay, so no, it should be running actually. I'm not. Okay, fine, no problem. So yeah, one hit. Now I'll hit from here multiple times. Watch using watch command. So every 2 seconds it will hit, and you can see that here. See logs. So using this command, you can get to the logs of the container. Docker attach. I'm assuming like you have done it. So something like a Docker attach you have here also. So you can attach to the running container. So see it here. See, from here I'm creating a generating a traffic, right? Which you can see it over there. Okay, so this is the attachment. You have studied exec also in a Docker. Here also you can use with the kubectl. So you can run any command inside a container of that pod. So kubectl get pods. What is this? Okay, sorry, I'm inside. No. Okay, I was running in the worker where the workstation is not set up. Get pods. I want to run inside a container some commands. So how to do that? So kubectl exec pod name and ls. See here. This is inside a container. Yeah, so you can run any command inside a container using this exec command. So using exec command, if you remember, you can go inside a container also. So docker command here, it bin bash. Where are you right now? Any idea?
At the container.
Inside a container. So that's the reason I ask you to study all the options of Docker. Sorry. So it will help you. So yes, exec command also you can use it. Now guys, in container Docker, you guys have used -p option, right? All of you.
Yes.
So here we have a port forwarding option. So how do we do that? So see here, this container, this pod basically here, I'll come out of it. kubectl get pods -o wide. See this pod IP address I cannot access from outside. Inside a cluster, I repeat, inside a cluster it is available, but outside of the cluster is not available. So what do we do in this case? So we'll have to do the port forwarding. How do we do that? So kubectl port forward. I'm forgetting the command, so -h. Here you have so many examples command. Okay, try it out. I think I need this one. Logic is very simple. kubectl port forward address from everywhere for everyone. Which pod? Pod name is get pods. This is the pod name. And first one is the node port. Second one is the container port. So container port 80, I know that. Node port, I'll let it be anything. That's not a problem. 8888. So here, enter. Forwarding right now. And now let's check it out. IP address of node, which is any node, you can pick it up. 888888. 888888. Yep. So why it only accessed on the master? Because I'm forwarding at the master. If you forwarded at the each machines, you can access that one also. So here, got it. So this is also, you can do the port forwarding. You want to copy some files and folders inside a container, you can use cp command. So how can we copy that? So let's check it out. kubectl get pod. There's a file which is this one. I want to copy. So kubectl cp file name. Which pod you want to copy here, and inside that where what exactly tmp locations. Can we see that? kubectl exec this one ls/tmp. See here. You want to bring back the copy from there to back to the host machine, that is also possible. And last command which is in this troubleshooting area is auth. Inspect the authorization. So what kind of access you have? So basically I have a admin access. So how do I check auth? You have two options, can I and reconcile. So can I means it will ask you. So can I create pod? Yes. Create svc, create ns namespace. All is ss because I have admin access. So you can check that some of the resources, if you have not got access, you can check it out this one. So guys, did you understand that, all of you, how to work with the pod? So I did the crud of the pod, and also some of the troubleshooting commands. Are you understanding?
Yes.
Okay. Next one is so replication controller. What is this? This is another services which is called replication controller. So what you are going to do with the replication controller? So replication controller basically, see, if you notice here, I'm always getting one pod when I deploy the kind is equal to pod. But in reality, I do not want pod, I want 10 pod. I want 10,000 pod. So how do I do that? So for that, we can use the replication controller. Replication controller means this has a two property. One is like you can get a multiple pod, and the second feature is interesting. Second feature is whatever that you got the pod, that will be always inactive. That means number of pod will be always controlled. That means you cannot increase one, one more and one less. So let's say if let's say you want 10 container, 10 pod. So out of 10 pod, let's say 5 got deleted because of some reason automatically, or maybe due to some corruption in the cluster. So remaining 5 will be immediately, with a blink of eyes, immediately it will be replaced. Are you understanding?
Yes.
So let's try this replication controller here. Example code I needed. So here Kubernetes example replication controllers you have here. So check this out. Now this is the code. Copy it, and I'll show you this. So here, let me delete all these extra comments and all. It spoiled the VI editor actually. Yes, what you want? Replication controller. What is the name of it? This one. How many replicas of pod you want? 3. What is the spec of the pod? Here. Labeled with this one. Comfortable with this code?
Yeah.
So same thing, we have to do the CRUD on the RC now. So here virc.yaml and save it. Here kubectl apply -f rc.yaml kubectl get rc. Here you see 333 get pods. You have 3. You look at this here, this 3. The first one is I created before that. So 3 is running now. So can I edit this? So edit RC and replication controller. Let me mute you guys. So here, how many RC you want? Earlier 3, right? Can I increase that to 10? See the magic. See. So you could have done, if you have a large infrastructure, 1000 also. Are you able to understand, visualize this power of Kubernetes now?
One question I have. So when we talk about auto scaling, does that also edit the replication controller internally when it happens?
Yeah, right now I'm doing the manually, but there's one component which is called HPA, which can do automatically also based on the rules.
Okay.
Okay, so I'm showing you manually, but there are more than 72 API resources we had, remember? So there are many resources. That's our job actually, to run the API resources.
So this when you do the auto scaling, Rajesh, so will the containers be spread across the worker nodes?
Yes, look at this image here. Correct now? Pod, not a container, pod. Inside a pod you have a container now. Understanding?
Yeah.
So I have only one worker, so right now everything is created in one worker. Okay, so here 10. Can I reduce it? Look at this magic. Go replicas, make it 2 only. See here. Terminated. Everything got terminated. See. So this is the power of Kubernetes. If you have a cluster, you can make it 1000 within a second and stuff like that. So these are the applications you are running, each applications you have. So this is the one feature of replication in a replication controller. The another feature is controller. How? Let me show you here. Look at the magic. Edit that one. Live editing I'm doing. You can modify the file and apply also. That is also possible. So let's make it 20, okay? Now you got a 20 pods. See? I think 4 GB RAM I'm having. This is an Nginx container. So 4 GB RAM 20, I think it should handle that. There is no traffic right now. Yeah. Now guys, look at this age. What is this age? All of you? Are you able to look at this age of the container pod? Correct now? Hello?
Yes.
Look at this. This is a 4 minute. This is a 4 minute. And RC means replication controller has a feature. Whatever you desire, it will be maintained all the time. So see, by accidentally, I'm deleting 2, which is a 4 minute. kubectl delete pod, this pod, and this pod. I deleted. Mistake can happen manually. See that? Did you notice something?
Creating the two new.
Yeah. So if something happens in your cluster, let's say in odd hours, no one is required to fix the issues. Kubernetes will auto heal everything automatically. Okay. So this is a replication controller. All of you are comfortable?
Yes.
So now let me delete this replication controller. Delete RC, name of the RC, and done. So kubectl get pods, gone. Now next one is next resources deployment. So guys, you know what? Deployment, you know what? Replication controller, the one which I demoed to you, that got deprecated actually. It's working right now. It's working right now, but it got deprecated. That means in a future version, this will be removed. Then you'll say, then what is the replacement then? So replacement for the replication controller is replica set. Yeah, replica set. Then you will say, why I'm not talking about the replica set? Why did I talk about the replication controller? So basically, replica set and replication controller, there is no difference. Here RC, RS, only the name difference, behavior is almost same. So whatever the command I used to create a replication controller, you can use the something similar to replica set, only name will be changed. Everything is same. So basically whatever the bugs we had in the replication controller fixed with replica sets. On top of that, you know what? Deployment, which is, I told you, it's ASD++. Many features which we have in the deployment, many features. And deployment has one feature which is called replication controller, which is coming from replica set. That means when you go and create a deployment, this is the ultimate API resources which everyone uses for deploying the pod. I repeat, anyone in the Kubernetes, those who wants to deploy the pod in the Kubernetes, they use the not a replica set, not a replication controller, but deployment API resources. So deployment internally call the replica set actually, which is the fixed version of replication controller. So now I'm going to show you the deployment. Deployment has many features right here, and this is production ready API resources. Lots of things you can do it through the deployment, but I'm going to show you some of the features with the command line. So yes, any resources which you can create through the YAML file also, and you can also create through the command line also. So this is up to you. So let's get started. So here I am using deployment. So let's start with the command line. So kubectl create deployment. Deploy is a shortcut, you can use it. Rest of the command I don't know. -h, and here many examples you got it and stuff like that. So this command you can use it, this command you can use it, and stuff like that. So I'm using this command. Image name I'll change it to mine. This is the stuff. Okay, so this is the deployments. kubectl create a deployment named with mydep. Image is this one. 3 replicas you should be having it. So clear the screen, enter kubectl get deploy. See, get pods. See here. So these are the 3 pods. Let me delete this pod, is unnecessarily confuse you. kubectl delete pod, done. Now 3 pod you have it, which is a part of the deployments. All got created at the same time. Can I edit the deployments? Same way as you did with the RC. Mydep, deployment name is mydep. I want 3 to, let's say, 10. See here, 10. I want from 10 to 2. See here, 2. So guys, are you understanding, all of you?
Yes.
So it has a replication controller feature also. How? Let me delete this and see the magic. Delete this pod manually. Accident may happen. Pod. Manually I'm deleting the pod. Look at the age, 62 seconds. See that? So deployment is a more stable. Deployment is a more stable, and it has a feature of RC, replication controller. But here I'll trace you. See here. Look at that. Let's trace the pod. I'll teach you how to trace. So if you go to the describe this pod, which you know that now, describe pod, and this pod, if you read it little detailed, so here it's controlled by replica set. See that? This is the replica set. What is the name of the replica set? This is the one. Can you see that replica set now? kubectl get rs. See here, this was the replica set. Now if you describe this guy, then you will see that this replica set is controlled by deployment. See here, correct? Huh?
Yes.
So that is how the relation. That means here what they are doing, they have a multiple API resources, multiple functionality, and they are inheriting the properties of each other like that. So that is what is happening. So now this is the deployment. So then you will say, Rajesh, I did not see any differences between the RS, RC or deployment. So actually differences are there, and differences you will have it during the deployment strategy. Okay, so I would request you to read this Kubernetes deployment strategy. Okay, you have to read it. This is the interview question, by the way. Okay, so you have to read this one, and spelling mistake actually, maybe. No. I was having one blog, very nice one, for deployment strategy. Not sure where is that. Just a second. It should be here only. Huh. This is the one. So here you have a multiple deployment strategy, which is very popular in the IT industry for deploying applications. And you know what? I would suggest you to spend at least 1 hour on this. Recreate ramp, blue, green, canary, because at least 2 to 3 interview questions will be asked from this. Okay, so very important. Each interview in the DevOps or SRE will be going through this. So spend some time here. I'm putting the URL and this. And specific to the Kubernetes, these are the deployment strategy which we have, which is to recreate and rolling update. So this is the strategy which we have. So right now I'm teaching you rolling update. Rolling update means, look at this here. In the replication controller, there is no as such strategy. Are you able to see my screen?
Yes.
So see here, how many pod you have in my current deployment? 3. The version of the pod is 1.11. Okay. So now the challenge is, how can we deploy the new version of pod and without even millisecond of downtime, and plus without having the problem end user experiences issues and all. Means number of pods should be the same all the time, so your downtime is 0. So look at this image number 1, and the deployment strategy which you use is this one, rolling update. So here one old version of pod got deleted and one new version of the pod got added. This will happen very fast, don't worry about that. Again, second old version of pod got deleted and second old new version of pod got added. And third one, by now you have a complete upgrade done, and any given point of the time, if you count the number of pod, it will be still 3. Are you able to understand this?
Yes.
So this is called rolling update. There's one more version there's one more deployment strategy available, which is called recreate, but I'm not discussing, you'll take it offline. So how do we do that? So let's visualize all this stuff. So for that, I need to have a commands. So all the commands I shared here only. See here. Deployment and replication I showed you. Deployment and controller I showed you. Now I'm showing you rollout and versioning. So these are the commands I'm going to use it for roll out the new version. Okay. And after that, rollback also. Okay. So I'm just using this command for the copy paste, so it will be easier for me. So let's get started. So first thing, let me delete that deployment. I have to create a new one. So I'm deleting kubectl, delete deploy my deploy. Okay, done. So what next I have to do? I have to check the commands, which is rollout command. This is the command which will help me for deployments. It will work with the daemon set also, and it will work with the stateful set also. These are the commands which we have. So if you want to roll back, undo, you want to check the status, resume, pause, history means versioning of deployment history, and restart. So here I am going to deploy the command to deploy is here. Okay, so I'm going to deploy this one, but if you look at this in this document, I have used here and all stuff like that. So let me show you the versioning first. Let's deploy one more time, fresh one. Done. After that, I'm going to show you history of deployment for that MyDev. See, there's only one deployment. What is the image name? Look at this here. Image name is v1. Okay. Now I'm going to deploy. I'm going to show you the IP addresses for it. This is the command wrong. This is the right command. Sorry, these two commands are wrong. Okay. Clear the screen. This is the IP address. Let me show you the pod actually. Perl HTTP. See, this is the first version of the software. Welcome to devopspool.com v1 and history, which I have shown you already. And now I'm going to change the my deployment and change the my deployment and make it the image name from the v1 to v2. So image changed, save it, and now let me see the pod. See that? See? So all the pods got redeployed the moment you change the image. Can we see that here? Curl HTTP. So did you see that the change has happened from the v1 to v2, new version of software?
Yes.
So that feature is there in the deployment. So can we see the history of it? See, here is a v1, this is the v2. So I deployed the new version of software. Okay. Now why you did not realize it? Because of that only it was the 3 pod. It happened so fast. Look at this. First it happens, then this, one by one. So all this logic is there in the deployment. If you describe the deployment, you will see that logic.
One question I have: if we don't change anything in the deployment and the deploy, does it again change the version?
No, version will change when you have an image change, because image will contain your applications, no? So if there is no change, then there is no need to change the version also. Correct, no?
Okay. Is it just the image change or any change in the deployment itself?
Deployment is just a way to deploy the image itself. So image change means application change. Simple.
So
Application change means version change.
I mean, let's say we change the replica sets count when we
Then
deploy it.
will not. No, the version will not change.
Okay.
Okay. So then version will not change. Version will change when you change the application. That's a version, deployment version. Okay. So here you got it. Now you did not able to see that, but let me show you this one. Describe it. kubectl describe, same command more or less actually. And if you go to the strategy here, look at this here. So strategy type is rolling update, and the policy is like this. What it says, 25% make it down, and then 25% of the pod make it up, and this way you complete the deployment when it is in case of new version of image change. Are you understanding?
Sorry, can you please repeat one more time? I got distracted.
Let's say if you have hundreds of pod to be deployed, so 25 they will bring it down, 25 they will create with a new version, then again 25 bring it down, 25, same way which I discussed here in this image here.
Okay.
Okay, so now let's do this and let's check it out, the rollback feature. So rollout you can do at the large scale, again you can check it out. So a few more commands, so I'll do that in front of you. So one more time I have to do that. So let's delete this kubectl, get deploy. So delete this and deploy and my dev. I'm creating one more time. So here this is the command. The only thing is this time I'm creating replicas 15. So you can visualize this. Dup created, see the history quickly, and see the status of role deployment. See that. Now it's because you have a 15, it will show you the status one by one. And I have only one worker. So little seeing the update, little delayed actually. Done. Rollout is successful. So now you have a pod, and these are the pods you have it. Now again you can check the IP address deployment which I've showed you. Now you can edit this v1 to v2 and see the how it will get deployed. So this image has been created already for this demo only. See the history 1 2, look at the status of deployment, changing the images one by one here.
Is it doing it in the group of four?
Up 25%, no?
Okay.
And then you see here, you see the age, you'll have some differences. because they do it in a group of 25% or something. Okay, now the question is, how do we roll back? So it's very simple. Look at the code. This is the, here you have here we have, let me show you this, curl welcome to devopsschool.com/v2. I want to go back to the v1 without even single second of downtime. So this command will roll back actually to v1. Undo, rollout undo. See the status quickly, rolling back status. See here, this rolling back one by one. The strategy is 25%, by the way, the one which I discussed. Almost done. Now can we see that whether rollback has happened or not? Check one of the pod. See, tell me, happened or not?
Yes.
So this is the, you see that ease of, you know, deploying application, rollback application, and all stuff like that. Immediately want, let's say Flipkart big billion sales is going on. So I was running with a 500 pod. Suddenly I need a 5,000 pod. You don't have to do anything, just one command. You want to reduce it, one command. You want to upgrade it, one command. You want to downgrade it, one command. By the way, this command also you don't need it if you use Argo CD. New tool has come in the market, which can help you to automate this one also. Are you understanding, all of you? Deployment.
Yes.
Yeah. So this is the most important API resources what you have, which you have to understand this. Now, last resources which I am going to talk about is service. So what is service? I forgot. Understood?
Yes.
All of you? So guys, see, I have so many pods. I don't want to access the IP address of the pod. I don't want. All are Nginx pod. I will. How do I know one from the end user perspective? How do I do that? So let's understand this way. Very important concept. Okay. I have a detailed video of 2 hours on the services only. You can check it out. So now this is a one worker. This is another worker. So think simple, okay? This is a one pod. This is a one pod. This is the application pod. Now here we have a backend pod here and here. This is a node has IP address. Pod also has IP address. And this is the boundary of cluster. My end user is somewhere outside. So you suggest me, how can we access, how can we allow there's a two question actually. How this front end pod, this is the green one is, let's say, front end, and this is the back end. So how this front end pod will talk to the back end pod, because back end pod in this image only you have two, but in reality you may have a 50. Correct now? So first internal communication, and then second question is how the end user outside of the cluster can reach out to the front end pod. Very simple architecture I'm showing you, front end and back end. What is the solution you guys have for this? Hello?
Create a service which talks to the pods.
Yeah. So basically service means load balancer. Okay. This load balancer is free of cost in AWS. So this backend pod and this backend pod, you will create one service. Okay. So one service. So now this front end will talk to this service and this front end will talk to the service. Correct now? So this front end will talk to the service, here it will come, and this service, because it's a load balancer for the pod, it will transfer to here or here. Correct now, all of you?
Yes.
So that problem is solved. Internal communication problem is solved, and for that you need a service. So can we create this service? Now you know what, you will have one question in your mind, how this service works. That means how come this service will load balance this pod and this pod? That is a question. I can create a service. Let me create a service first and then I'll show you. So manually I'm showing you, all this can be automated way also, but I'm showing you manually because you will understand this. So create svc-h cluster IP. These are the 4 types of service I'll discuss about it. And this command will create a service. This command will create a service. Create service, name of the type of the service, name of the service, what is the type, I'll discuss in some time, service IP address, and service should hit to the pod port 80 I'm making it. So guys, here I created a service. So kubectl get svc shortcut. So I have one service available, Kubernetes service for the cluster, but I'm creating one service manually. See here, this is the service IP address, service port number. If I describe this kubectl describe svc mycs, see here endpoint, service is not balancing any pod right now. So the question is, how many pod you have? These many pods you have. So the question is, how this pod I can load balance this service? Did you understand the question?
Yes.
So that is where, you know guys, you have to do only label matching. You have to do label matching. So what is the labels of the pod? Let me gather this. So here show labels. Spelling mistake. See, each pod is having these labels applied. So I'll just copy one label, app is equal to my-dev. So here I'll go to the service, edit the service, and here there is one selector labels somewhere here. This I'm showing you manually here. So this label, this service will select all the pod where the labels are matching with my CS. So it was not a my CS, it was a my dep, right? Correct now? See here. So I'll just
Yes.
change this my CS to my dep selector label. That means this service will select all the pod which has that label. Modified, describing the service. Now you see that all the endpoints got updated. That means now if you hit the service IP address and port number, it will redirect to one of the pod as part of endpoint. Understood all of you?
Yes.
So can I try now? HTTP curl HTTP port number 5678. See, now I don't know which pod is showing actually. Correct now? I don't know which pod is coming. Understood all of you?
Yes.
So this is a service which balance the pod. Just now I created and kubectl get svc. This is the service. So now the question is, service itself I showed you, there are many types of service. See here, out of which I created cluster IP. So what is the cluster IP? What is a load balancer? What is a node port? And all that stuff. What is that? So for that, you know what? I need a 2 pod actually, and which I'm going to create it. So I'll delete the deployment. Get a deploy. Just to make you understand, kubectl delete deploy my dep. I deleted it. So now I don't have any pod actually. It's terminating. So what I'll do, I'll just create only 2 pod because load balancing I can show you. So pod dot YAML to pod 1 dot YAML. So 2 you have it, pod. Change the name of the pod. This is the pod 1 and image is a v1. That's let it be. And here pod 1 here I'll make it 2 pod. Sorry, here name pod 2 and here image is different image to display. So got a 2 pod. Now what I will do is I will apply this both the pods. So apply -f pod.yaml pod -.yaml and done. Now kubectl get pods, 2 pods, get -o wide 2 pod, you got it, IP address. Let me prove this, curl HTTP done. v1, this one 99 v2. Now I want to show you some labels also. So show labels, spelling mistake, labels. Here is this one. So are you comfortable with the 2 pod why I created? Because I want to show you the load balancing. If it is a similar pod, you don't know whether load balancing is happening or not. Correct now?
Yes.
So what I will do, app is equal to hello world. So I will edit the service So get svc, and here edit svc my cs, and here selector will be hello world, app is equal to hello world. Now save it. Now get svc, describe svc my hyphen cs. See, only two pod is there, correct now? So match the
Yes.
label. So now if I show you load balancing, you see that watch curl http 5678. See, v1 is taken v1 all the time over. v2 now, see, v1 again, v2 again. So load balancing is happening, correct?
Yes.
All of you are understanding, right?
Yes.
Okay. So now the question was, okay, so internal load balancing, we solved it. That means we have a one backend pods, one service is there, and if front end wants to reach out to this, then they can talk to this service. But
Just question here. So this would mean that we would ideally don't create same service containers in a pod twice. Like we can have multiple containers, but it's not a good idea to create two containers in a pod with the same service, because there the load balancing will not happen, or will it happen
no,
at the pod level?
different port, it's a consistent across all the pod. Different port, then it is possible. Because here I'm load balancing at the 80 port of the each port. So port
Yeah.
number should be consistent. If
So
you're running
when you say the port, right? So it's actually pointing to the single pod port is pointing to single container at this moment.
no. See, understand this way. Pod, I'll put it in a more simpler way. Your laptop is having no any association with the port number. Your laptop get IP address only. So the question is where the port number is getting allocated. So port number you embed in the application, like Apache configuration you embed 80, Tomcat 8080. So there. So now coming back to the container world. So if you want to run some container with some port, you embed in the image itself, and then IP
Yes.
address. With that help of IP address, you can reach out to that container application. Correct now?
Yes, yes. That
So
that
in
part I
that,
understand.
yeah.
Yes. So let's say the pod has two containers running. Right now it's two different pods, right?
Hmm.
Let's assume that it was both the containers were running in the same pod.
Hmm.
It would
So
not be able to load balance that, right?
why not? Okay, I'll put it this way. Let's create an image, another image. This is a one pod. This is another pod. And here you have one application Apache. Here Apache. Here Tomcat. It's running on 80 port. It's running on 80 port. Here running on 80 port. Here running on 80 port. Now, what do you want? You want to create a service, correct? You want to create a service. So you
Yes.
want to have a one port 80 for service mapped to this and this. Another port for service 80 you map to this and this. It's possible, no? So that
Okay.
means
Yeah, I got.
end user will hit the service 80 port, it will redirect here or here. 80 port, it will
You
redirect here or here.
okay? So you would have to Like you cannot have two Apache containers in the same
Two
pod
Apache
with
you
the
cannot
same.
have, no. It's against
Okay.
the rule of networking.
Yeah. Okay. Got it. That is what I was confirming.
Yeah. So, but best practices, you know what? Best practices like having only one kind of containers only. Okay. So now come back to the question, this image. So that backend service is ready, but that internal communication is set. But the problem for this guy, how he will access? So he want to access what? He wants to access front end. So what I'll do? So he will be able to access the front end. Tell me.
Yes.
Tell me.
Yes, he will be using the public IP.
Okay. So public IP of what?
Public IP of the gateway. The server who is acting as a gateway, in this case, maybe the load balancer itself.
No, load balancer IP address is not accessible from outside. That is the problem, no? See here. This IP address, I'll show you that. This is the IP address, no? I will hit it from outside.
This is a private IP. It will not work.
Yeah, it will work only in the cluster.
Yes.
So what we'll do?
We would have to have a external load balancer of some kind.
So first thing, if I understand the architecture well, first thing, let me create one more service. And this time this service will load balance the front end. Agree with me? So here, if I am inside it, think about it. Inside a cluster, I will hit this service IP address. Service will transfer the pod of the front end. Front end will go to this service, which is our back end. And back end will redirect to one of the back end pod. Are you comfortable so far?
Yes.
But I was inside. No, I was inside, so it was okay. If I'm outside, there's a problem. So what to do? So that is where this service, whatever you have, this IP address, no? Service IP address, please hear that. You have to forward at node port. Did you see that? You can port forward the service IP address at the node port at certain node IP address and port number. So now can this guy access the node port if firewall is allowed?
Yes.
So you can access it. So now the question was, the service itself is having multiple types. Understand this. So service itself is having multiple types. One is, I showed you, clustered IP. So clustered IP means the service, and clustered IP means the service get created and the port number which got exposed to the service, which is accessible inside a cluster only. That's the reason you were able to access all this inside a cluster, but from outside, no. This is the cluster IP. You see the type. So then you will say, Rajesh, what is the node port? Second type. So node port, what happens? In the node port, service get created, which is one. This service get created SVC of cluster type. But plus also this service get exposed at node port also. Node port means each node of the each node at certain port. So this service, why I created two image. So if you expose this service with the node port, it will get accessible here also and here also. So that we call it service IP address. Are you able to understand this?
Can you please repeat just one more time? If we
First,
expose it to the node port?
yeah, look at this here first. Look at the image first.
Yeah.
So here, what I want, this guy wants to access this node port here or here. So this service which we created with the cluster IP get exposed at the port forwarding at the node port. So how can you do that? How can you do that? So node port, how can you do that? So here you can do it using the command line. I'm creating a new service, okay? And here, this is not, I'm creating a new service named with node port and type is equal to node port. So this will do two things. Okay, so I'll call you node port. So what will happen? Let me create a just a second, give me 2 seconds, guys. So can you hear me, all of you? Hello.
Yes.
Yeah. So here what I'm doing right now, I'm creating a service, but this time exposing at the node port. So new service will be created, but this time both clustered IP also you get it, and that will be get exposed with the node port also. Let me do that. Okay, there is a problem here. This is not required. This is the one which you need actually. So kubectl get nodes, get SBC. See here, look at this. This is the node port I created. So here you see that this service got a cluster IP also, which earlier I got it. And the service cluster IP port number is this one. But here we got the type node port. So what has happened? This service get exposed at the node port also at this IP address, at this port number. So now let me load balance the pod to this. So let me edit this pod, edit SBC, mynp, and here selector pod. Where is the selector pod? Here, hello world, labels of the pod, save it. Now if you describe this to describe SVC, so two pod is there. So now you see that here Oh, sorry. If I hit this one, curl http 5678, enter. See here, v2 v1. So load balancing is happening, but now this pod is accessible at this node port also. So let me show you the node port. Node port means first node IP address. Any IP address you can take it up, and 30996. See here. So that means this guy is able to access this node port now. Correct now?
Yes.
So this is the node port, second type of service. This is the
Uh,
second type.
One question I have here. So now the traffic is hitting the port of the second node here, right? And
Yeah.
then it is being routed to the service. Is that what is happening?
Yes. So from here it is coming here, and then from here it is coming here, is going to the front end pod, from front end to the backend service, from the backend to the backend pod.
Okay, got it, got it. Okay.
Yeah. So now this is the things. But tell me one thing, guys. Have you ever hit the IP address of and port number of node? No. This is a secure information. So what we need to do? So we need to create a one load balancer outside. See, this service is also load balancer, but service is a load balancing the pod one inside a cluster. But this load balancer we need outside of the cluster. Who will create it? Those who manage this node. Who manage the node? AWS or Azure or something like that. So this load balancer is external load balancer balancing the your VM virtual machine such. Okay. So that is a third types of load balancer, which is called load balancer. So service is also multiple types, right? So clustered IP, node port I just showed you, and third one is load balancer. So load balancer you cannot create here because this will be created automatically in the EKS, AKS, GK and all. Manually you can create a link that is also done. And now you will hit the load balancer. So you see the traffic, load balancer to node port to the front end service to the front end pod to the backend service to backend pod. Now people are not hitting the load balancer also. In between they are having domain name DNS server like www.devopsschool.com. So here this you can, if you know that AWS Route 53, you can create a DNS server. From here network load balancer you can create here, and then whole setup will work like that. Understood all of you?
Yes.
So this is a service. This is a service. So guys, this was the most important one what we had it. Apart from that, you know what, many commands are there which you need to study. kubectl. See here, half of the command I taught you, but if you are an admin guy, administrator, cluster administrator, this command will help you for managing the worker node and all. If you want to do the some automatic auto scaling and all, so you can do this one also. And API resources, there are so many, so only I taught you only most important one. But here you have, for storage there is a API resources. This is the resources for access authorizations. Okay, these are the resources for authorizations. And storage, you have some of the resources for creating volumes, PVs, and all this stuff like that. Okay, now for the security also, so if you study little bit this one, let me make it clear the screen. Yeah, see, so you have to study most of this, depends on the requirement. Just like remember in AWS we had a compute services, storage services, networking services, security
Yes.
services, like that, and multiple soft platform as a service, software as a service, like that also only you have this one. So here I showed you some of the services, but yeah, all kind of services you have here. So let me show you here. See here. So this is a apps, you can say platform as a service or something like, or this is authentication, authorization. This you can ignore it. CRD. This networking Calico. I've used it. This is again authorizations. This is a storage here somewhere downside. This is the networking policies related. These are the foundation services. So I taught you the foundation services only. So I taught you pods, I taught you nodes, namespaces, replication controller, services. So these are the foundations I taught you. So now, yeah, first what you do, whatever I did in this session, you do it without having any doubts and question. And after that, you get into the detailed one, 20 hours of videos which you have, and detailed one, and try it out. Any questions, guys?
I
Any?
have one question. So, because Kubernetes is quite big, like in general, when you want to learn, there are a lot of things to cover here, and
Mhm.
this is something we cannot really cover in one day per se.
Yeah.
So, and and also in the organizations, in the companies, you have different roles, different people doing different things in the Kubernetes cluster itself.
Yeah.
What would you suggest for an SRE to focus on most in the Kubernetes? What are the
See,
parts?
I'll put it in this way. It's all see. You go to the AWS, and what you learn, it depends on what are the services you are using. Correct, now?
Yes.
So when you go to the project, also first locate that what are the API resources they are using. They may not be using everything. Maybe using 15 or 20 at max. See, I have seen the organization who's working only on Kubernetes and not using more than 18 services because not needed. Got it?
Yes.
So
Correct.
look, go to that YAML file, Helm chart and YAML file, and look at the kind and list
Yeah.
out and only prepare for those. Don't target everything, others will become a Buddha actually.
Okay.
Okay, any other questions, guys?
One more question I have, slightly off topic from Kubernetes.
Mhm.
So it's more kind of personal to me. Is I wanted to handle something like event-based trigger in Kubernetes, which we currently use some external services for that.
Mhm.
So we have horizontal pod scaling, like horizontal scaling in
HPE, yeah.
Kubernetes. Yes.
Yeah.
Is it possible to have vertical scaling, like the scaling of the individual pod or node itself, like kind of auto scaling vertically?
Vertically, there is no requirement for that in Kubernetes. Okay. So the vertical auto scaling which you'll do is at the node level. See, vertical scaling means increase the nodes. Horizontal scaling means increase the pod. So if you want to increase the node, then talk to AWS auto scaling group. If you want to increase the number of pods, then talk to this one. What is it? HPA. So that is something which you can do.
Okay.
Okay, guys. So yep, I'll see you next session. And meanwhile, if you have any question, please put it in the WhatsApp group. We'll respond it. Bye, everyone. Have a nice Sunday.
Thank you.